Hey all, this is Mr. Carey again, and I'm coming to you with another GoMath 4th grade lesson. And today's lesson is going to be lesson 5.2, Factors and Divisibility. Now, if you recall in lesson 5.1, we started to really just kind of get into factors and drawing arrays and really just getting the basics of having a number and figuring out what the two factors are of that number. Well, drawing arrays, while it can be fun, everyone knows I do that in my spare time, it's not really the most efficient way to figuring out factors. So we're going to learn another way, actually probably 3 ways of how we can find different factors. So let's start off with looking at our unlock the problem. And I'm going to highlight what the essential question is real quick. I'm going to highlight it in green here. And the question is, how can we tell whether one number is a factor of another number? All right, that's going to be our underlying question throughout this lesson. So we're going to start off here. Students in Carla's art class painted 32 square tiles. They will arrange it to make a rectangle. So can we have 32 tiles arranged into 3 equal rows without gaps or overlaps? Okay, so that's a really kind of long drawn out way of asking, is 3 a factor of 32? All right, so that's a real kind of long, wordy kind of word problem way. All we need to find out, if I have the number 32, is 3 a factor of that? All right, so one way we can do is we can try and draw a model. So what I would probably do kind of makes the most sense to me. You can either do it in groups of 10, groups of 9. I'm going to try, let's do 9. Yeah, I don't know. Let's try this. We have 2, 4, 6, 8, 10. All right. Then we have another 10. So that's going to be 20. And I have 30. All right. And now we have our rows. So now let's go 31 and 32. So it looks like we can't do that because we have 11 in this row, 11 in this row, and 10 in that row. And we need to have it into 3 equal rows. We can't. So unfortunately, that doesn't really work. So a rectangle, and this is where we're going to write in here, a rectangle cannot have 32 tiles arranged into 3 equal rows. And that's all we need to figure out. So we're done right there. And that's the one way is, I'm going to kind of pretty this up a little bit, is we're just drawing an array, right, to kind of figure this out. We know we need to have 3 rows. So all you do is you just start kind of putting your blocks in there into your 3 rows. And that's great for low numbers like 32, but for larger numbers, it's going to get kind of tedious. And it's also going to use a lot of graph paper. So let's figure out another way we can do this. And that right here, another way, I'm going to highlight this, is we can just use division, right? And what it's telling us here is if 3, and I will highlight this in gold, if 3 is a factor of 32, then the unknown factor in 3 times what is a whole number? All right, like, whoa, Mr. Carey, what do you mean whole number? What does that mean? Well, that's the math idea, right? A factor means that I can take a number and I can divide it evenly. And that means that my factors are going to be whole numbers, right? Anything, 1, 2, 3, 1,849,000, it does not matter, any whole number. So an example of not a whole number, would be, 1/4, 0.56, 9/10. Those are all not whole numbers. So if I come up with an answer like that or have a remainder, well, then that's not a whole number. So we need to have a whole number with the remainder being 0. So let's try this out. 3 divided into 32, or 32 divided by 3. So our first step, divide. Remember, divide, multiply, subtract, bring down. So divide. 3 divided by 3 is 1. Multiply. 1 times 3 is 3. subtract 3 minus 3 equals 0, bring down, I have my 2. Now this is where some students get kind of confused. How many times does 3 go into 2? Or 2 divided by 3 gives me what? Now, yes, if we were to actually do it, we'd get a fraction, but we can't do that here. So the answer is just going to be 0, right? Because if I have two numbers, how many times can I divide them into 3 groups? Well, the answer is I can't. So it's going to be 0. So that's my answer, 10 with a remainder of 2. Or if you want to do the fraction form, 10 and 2/3. Okay, so now we have to go back to here. The unknown factor, and let's go switch back to here. The unknown factor in 3 times what equals 32. Is it or is it not a whole number? I'm going to say is not. So a rectangle can or cannot have 32 tiles arranged in 3 rows. Well, it cannot. We cannot do it because 3 is not a factor of 32. Okay, so now we need to go down to here and answer this. Explain how you can tell if 4 is a factor of 30. So again, we already learned 2 ways. One, we can draw a model. But I like this way. Instead of drawing models, let's just use division. And we're going to see if 4 is a factor of 30. Now, some of us are already shaking our heads saying, well, clearly it's not. But again, work with me here. Let's do some division. And for those of you that are saying multiplication, we'll do that as well. So let's have my 30, put it in my little division house, and then I have 4. So 4, how many times can 4 go into 3 tens? It can't, so I have to make 3 tens into 31s. So what is a basic math fact that gets me close? What times 4 gets me close to 30? And that's correct, 7. So 7 times 4 gives me 28. 30 minus 28 is 2. Remember, I had to regroup, turn that into a 10. And now I have 2. So how many times can 2 be divided into 4 groups, or 4 divided into 2? Well, the answer is, going to be 0. But we're done, right? We have a remainder. We can't go anymore. So 7 remainder of 2. Or, if you want to be fancy, 7 and 2/4, otherwise known as 7 and 1/2. So that 4 is not a factor of 30. We don't have a whole number. So in our explanation here, especially when you do tests, how can we tell 4 is a factor of 30? And you say, I divided 4 into 30 and did not get and I'm running out of kind of room here, but did not get a whole number. I'm just going to put the number sign there. So that's how you can tell if 4 is a factor of 30 or is not a factor of 30. All right, let's go to page 206 here. So hopefully everyone's copied this down. I'm going to do my little magic here, and I'm going to go, and let's get out our page 2. And page 2 should be up on your screen now. Now this is kind of cool. This is another way with our divisibility rules by just looking at the number. Now, if you really want to, you can take any number and you can just start dividing numbers into it, right? And that's totally fine. But this is kind of a cool way, these divisibility rules. And I'm going to circle this in kind of gold because it's really kind of cool, right? Divisibility rules. So you're looking at a number, right? And some of them have divisibility. Most of the numbers do, but these are your basic ones, right, that aren't terribly complicated. And so a number is divisible, right? That's a key word there, by another number if the quotient is a counting number, right? Your whole number, and the remainder is 0. So let's take the number 72. So our question here is 6 a factor of 72? So yes, we could divide. We're going to use our divisibility rule. So let's go to here, and I'm going to highlight in red, right? We're going to do number 6, right? Because that's what we have, the number 6. All right. And the rule tells us if I'm going to divide by 6, the number must be even and divisible by 3. Okay, so let's test for divisibility. Is the number 72 even? And sure it is. Now, what is the sum of the digits in 72? So what I mean is I have 72. I'm going to break it apart into 7 plus 2. So 7 plus 2 equals 9. Outstanding. Now, is that sum, right, is number 9, is that divisible by 3? 9 divided by 3 equals 3. So all we need to do is just put yes. And 72 is divisible by 6. So 6 is a factor of 72. Now, we don't know what the other factor is. We'd have to solve for that. But for now, we know that is a good way to test divisibility, to test if a number is a factor or not. So now what we're going to do is we're going to list all the factor pairs for 72 in this table. So how do we do this? Well, what I like to do is I'm going to start off with number 2, right? We already have 1. 1 times 72 is 72. And then our factor pairs go here. So let's start off with the number 2, right? I already know 2 is going to be a factor of 72. And then you're probably saying, but, Mr. Carey, how do you know that? Well, let's go up to our chart, right? Our little table. 2, the number is even. That is the only thing it has to be. And fortunately for us, 72 is an even number. So 72 is divisible by 2. So now for us to actually solve this, well, what we need to do is we need to divide. So going back to the other page 205. So let's take 72 and divide it by 2. So 7 divided by 2 would be 3. Multiply. 3 times 2 is 6. Subtract. 7 minus 6 is 1. Bring down my 2, and now I have 12 divided by 2 would be 6. Multiply. 6 times 2 is 12. And guess what? I'm done. So 2 is a factor, and 36 is a factor. And then I just write my pairs here, 2 and 36. All right, let's go to the number 3. Now, I'm going to erase my work just because I don't have a ton of room here. Now, let's look at number 3. The sum of the digits. I'm going to highlight this in red. The sum of the digits is divisible by 3. Now, cool thing for us, we've already done this work because the sum of the digits is, and I'm going to go back up here, I'm circling and pointing arrows up here, it's 9. So, is 9 divisible by 3? You bet it is. 9 divided by 3 is 3. So one of my factors is 3. Now I need to figure out what the other factor is, so we just go into division. So 72 divided by 3. 3 times, or 7 divided by 3 is 2. 2 times 3 is 6. 7 minus 6 is 1. And then I bring down my 2. Now I have 12. Now, 12 divided by 3 is what? Is 4. 4 times 3 is 12. And lickety sprout, I figured it out. I'm done. 24 and 3. So, 3 and 24. All right, now we can go on. Let's try number 4. Now, there's no divisibility rule here for the number 4. So we just have to, do division. 72 divided by 4. 4 times, looks like 1. 1 times 4 is 4. 7 minus 4 is 3. Bring down my 2. Now, 32 divided by 4. Hey, that looks like a basic math fact. So, outstanding. So 8. 8 times 4 is 32, and I am done. My two factors are 4 and 18. 4 and 18. Now, here is a test. You're probably asking me, well, Mr. Carey, why even bother with the divisibility rules up here if we're just going to divide? Well, that's a good question. Because why waste your time dividing every single number into 72 if you don't have to, right? If you can look at a number and go, yeah, I know 2 is going to be it. Do a quick add up the sum of my digits and I can find out if 3 is a number, is a factor. That's just going to save you a lot of time, and that's why we do it. All right, so let's look at the number 5, and I'm going to highlight up here my table in number 5. The last digit is 0 or 5. So if you have a number, whatever number that may be, so long as it has a 0 or 5 in it, it's divisible by 5. But unfortunately for us, 72 does not have a 0 or 5, so 5 is not a factor. Now we go into 6. The number is even and divisible by 3. Now we did this up here with 72. We've already figured that out. We already know that 6 is a factor. We don't know what the other factor is, so we have to figure it out. 6 divided into 72. 7 divided by 6 is 1. Multiply. 1 times 6 is 6. Subtract. 7 minus 6 is 1. And bring down 2. 12 divided by 6 is 2. 2 times 6 is 12. And I'm done. So our two factors are 12 and 6. Now, our last one is, we could, I don't think it's going to be 7. I mean, in that we're going to get to that down here. But what's a basic multiplication fact that we know? 72. What times what gets me 72? Now, what comes to mind is 8 times 9. And I forgot to write 72 here. Yes, 8 times 9 is 72. And now we write our factor pairs. Fill them in. And 8 and 9. And now, look at that. We're done. Now, how do we check if 7 is a factor of 72, right? So what we need to do is just explain, right? And the way we explain is I divided, I should probably do it before I answer. 72 divided by 7, right? So this is good. 7 divided by 7 is 1. Multiply. 1 times 7 is 7. Subtract. And then bring down. And then, so 2 does not divide in 7 times. So we have a big old 0. And then we have a remainder of 2. So that is not going to be a factor because it's not a whole number. So the way we answer this, I divided 72 by 2 and did not get a whole number. Guess what? That is your answer. That's all you need to do. How did you check to see if 7 is a factor? Just to tell me what you did. I divided 72 by 72 by, and see, no one stopped me here. I divided 72 by 7 and did not get a whole number. And that's how you know it's not a factor. All right, let's do a little practice here. And what I'm going to do is I'm going to do my magic again. And, all right. And let's go over to our last page. And this is Sharon Show, and then we'll do on our own as well. All right, so number 1 is for a factor of 28. Draw a model to help. Well, we can look at this and we know 4 times what gives us 28. And a lot of us know this math fact. 4 times 7 gets us 28. But again, what it's asking us, can you make a rectangle with 28 squares in 4 equal rows? So if I have 4 rows, let's do this. 1, 2, 3, 4. Let me write that a little better. 1, 2, 3, 4. Now, if we said 4 times 7 is 28, well, now we just need to write rows of 7. 1, 2, 3, 4, 5, 6, 7. And let's see what we have. We have 4 and we have 7. And then we can count these up individually if you want. 1, 2, 3, 4, 8, 12, 16, 20, 24, 28. So it looks like 4 is a factor of 28 because 28 divided by 4 equals 7, or 4 times what gets me 28? And the answer would be 7. Perfect. Now let's go over to these ones. I kind of like because we don't have to do a whole lot of math. We just have to answer this. Is 5 a factor? And then we go down here, is 9 a factor? But let's do this, is 5 a factor? Remember our rule for 5s, right? As long as your number ends in a 0 or 5, it is divisible by 5. So I'm looking at these. So 27 does not have a 0 or 5, so that's a big no. 30 does have a 0 or 5, and I know 5 times 6 gets me 30, so that's a big old yes. 36, nope, that's not a 0 or 5, so that's a big old no. And then same thing with 53. It's not a 0 or a 5, so that's a big old no. All right, now on our own, let's look at our factors, right? 9. Is 9 a factor of the number of 54? So how do we figure this out? Well, we can just look at this, and a lot of us are going, yeah, totally, this is, our basic math fact. 9 times what gets me 54? But let's just do the sum of the digits, right? Remember, our divisibility rule, if you turn back to your page, on page 206, divisibility rules for 9 are the sum of the digits is divisible by 9. So let's do 54. 54, and we're going to add up the digits. 5 plus 4 gets me 9. So is 9 divisible by 9? Yes. 9 divided by 9 is 1. So that's a big old yes. Let's do the same thing with 63. 63 is the same as 6 plus 3. That's how we're breaking it apart. Equals 9. And 9 divided by 9 is 1. So that's another yes. Now let's go over to 67. 67, 6 plus 7 equals 13. So is 13 divisible by 9? No, it's not. Now, if you're not sure, let's go back to our multiples. 9 times 1 equals 9. 9 times 2 equals 18. So 13 is right in there. And guess what? Not a multiple. So we're going to say no. And let's do the same thing with 93. 93. All right. 9 plus 3 equals 12. And then is 12 divisible by 9? We know it's not, but let's double check. 9 times 1 equals 9. 9 times 2 equals 18. And 12 is about right there. So that's another big old no. All right. Now let's list all the factor pairs in the table. So we're going to do our factors of 24. So first one, again, a lot of students forget this. Always do 1 in the number. Always, always, always. So 1, and that didn't work out. That was my highlighter. 1 and 24 equals 24, and my factor pairs are 1 and 24. Now let's look at 2. Okay, I know 24 is an even number. I know 2 is going to fit nicely in there. And if you know your basic math facts, you know 2 times what gets me 24? 2 times 12 equals 24. Now, if you are wondering where I came up with that, let's do the division. All right, I know 2 is a factor of 24. So 2 divided into 24. 2 divided by 2 is 1. 1 times 2 is 2. And then subtract, bring down 4. And then I have 4 divided by 2 is 2. 2 times 2 is 4. And that gives me a big old 0. So indeed, 12 is my other factor. Outstanding. Let's look at 3. So is the sum of the digits divisible by 3. That's our divisibility rule. Okay? Well, let's look at that. 24, 2 plus 4 equals 6. Is 6 divisible by 3? You bet it is, because 6 divided by 3 is 2. So I know the number 3 is going to be in there. Now, this looks more like a basic multiplication fact. 3 times what gets me 24? You're right, 8. 8 times 3 equals 24. 3 and 8. And then many of us know our other 24. 6 times 4 is 24. Now, again, this is really great if you're familiar with the numbers. And then you can just kind of fill them in, and it saves you a lot of time. But when you get to a number like 39, maybe a lot of us are not familiar with the number 39. Well, again, start off with 1 and the number equals 39. 1 and 39. Perfect. So, let's look at the number 2. Okay, I want to divide 39 by 2. Is 39 an even number? And it is not, so I can't use 2. And I only have one factor left, which is kind of nice. One factor pair. So let's go up to number 3. All right, the rule for number 3. If the sum of the digits is divisible by 3. Okay, the sum of the digits is divisible by 3. Well, let's do this. 3 plus 9 equals 12. 12 divided by 3 equals 4. So 3 is absolutely another factor. But we don't know the other factor. We don't know the pair. So now we got to do some good old-fashioned division. So 39 divided by 3. 3 divided by 3 is 1. Multiply 1 times 3 is 3. Subtract 3 minus 3 is 0. Bring down my 9. Now 9 divided by 3 is 3. 3 times 3 is 9, and I am done. So 13 times 3 is 39, and my factor pair is 3 and 13. And that brings us to the end of our lesson for chapter 5.2, factors. Join me for my next video. Is going to be chapter 5.3, and that's just before the mid-chapter checkpoint. Chapter 5 is a kind of a shorter chapter, which is nice. So it'll be 5.3, and then I'll probably throw the mid-chapter checkpoint up there after we take it, just to kind of review everything that we've learned. Again, if you have any questions, comments, concerns, complaints, or you just want to talk about factoring and division, you can always leave a comment. Always give me a thumbs up. Or if you didn't like it, think I, maybe just didn't explain something correctly, or you'd like me to explain something a little bit better, leave a comment. If you're going to give me a thumbs down, at least tell me why. This is Mr. Carey signing off, and I will see you back in action on lesson 5.3. See you later.